Hello everyone. Today I'm going to show you how to use Electric VLSI to develop a common emitter amplifier. So the very first thing you are going to do is to open the library. This is the library where we have developed some exercise. In the last lectures, we have successfully developed a capacitor and low-pass filter. Today, we are going to use the similar procedures, and develop the common emitter based on the NPN transistors. Before going on further, you have to make sure we do during the network consistency check, we don't do any comparisons of the transistor parameters, because in VLSI electrics, the transistors cannot be scaled. Now, first, tools, NCC, hierarchical comparison. Yes, these options will be checked. Check transistor sizes. You make sure this option is not checked. Other issue should be okay. And we are also have to check the spice simulator. Spice level is 3, doesn't matter. Okay, so far so good. Also, we also want to check if we have enough memory. Now we want 512 megabytes for the maximum memory, and we also want the maximum permanent space, at least I think I said 512 megabytes. Okay, apply, okay. Now the first thing you need to do is to develop a symbol for the NPN transistor. To start with, I will create another cell, so-called NPN1. Now I got the schematic for this. Now I'm going to place a schematic from here. Under the schematic tab, there's a pull down menu, and then I'm going to select NPN and make sure you have some area. This area is not going to be used anyway. Then we are going to develop some pins for this transistor. 1, 2, 3. Okay. So we are going to define the pins. B. This one is called C. And this one is called E. And perhaps here we need to define the model as well. In this instance, we are going to set the spice model for this. And I'm going to zoom in. And the spice model there's some delay. It's called NPN 53 DN. And I'm going to enlarge the text for this model a little bit. The next thing I'm going to do is to create a symbol for this. You go to the View tab and then make an icon view. So certainly you don't want this icon. You don't want to look at this icon. It looks ugly. So we are going to modify the shape of modify the graphic of the icons. Now we don't want this ugly. We can use the graphic from the schematic, and then we just pick this one there. And then we are going to place the pin in the right location. And done. And done. Then counterclockwise. We are going to decrease the size of the symbol a little bit. Now, basically everything is okay. Now, we are going to use this symbol for simulation as well. So, what we need to do is to create a XSpice template. This template will override any problematic spice statements. Okay, let's see what we can do. the easiest thing is to use Q and then QFXX and then the node name. Sorry, node name, and then the P name. C B E, and then the name of the model. In this instance, we are going to use a specially created model. Actually, this model came from a Taiwanese foundry. So we are going to move the text a little bit away. So we have the SPI code here. Now the next thing we can do is to develop the actual common emitter amplifier. So I'm going to create a new cell called CEM. CEM stands for common emitter amplifier, and we start from the schematic. Now the next thing we are going to do is to go to the cell to pick up the transistor we have created. Sorry, yes. So this will be the transistor symbol. Before doing this, right, let's do a DRC check. So we're okay. And we are also trying to do a SPI simulation and check what we are going to get. We have this pin, and this pin. It looks okay. It looks okay for us. It looks okay. Now we are going to create a common emitter. We are going to place the resistor in here, and then we rotate it. And for this one, we want 100. That's okay. And do not forget that, right? We need to change the width and height. For the resistor with 100 ohm, we probably need 40 as a width. Let's see, last time we have used 160 for 10Ks. We probably need 16 for 100 ohm. pin here. And then this pin is called VCC. And we want another pin here. This one is called GND. And we are going to create a bias network. Okay, that's what we can. That's the most basic form of the common emitter amplifier. And I want 1K for this resistor. $1K. And in order to get 1K, okay, so we want 16 here, that's right. And we want 0.9K here. So this resistor should be a little bit shorter. Say I would say 14, yeah, it's about right. Yeah, this one right, should be a lot smaller. I have chosen 16 to give you the resistive value, 1000. But now we want it to be 100, so it should be 1.6. And I will call this for the input. This one is called V-in. And obviously we also need another pin for the output. in the integrated circuit design, it's very difficult to create a big capacitor. So to solve this problem, right, you can create a common emitter amplifier without capacitors, and then you just ask the user to add the capacitor in the input and output pins. So this capacitor is a this capacitor will be external to the integrated circuits. VL. So far so good. So I'm going to do some cleanups and check the DRC error. So far so good, no error. Now I'm going to simulate these circuits. So I'm going to add some spike hooks to simulate this circuit. First of all, we are going to develop a capacitor at the input. We create another pins, artificial pins, which is not in the integrated circuits. And then the capacitor is connected to from the artificial pins to one of the bond pads in the integrated circuit. So I can just use 100 mil and then see output, and we can do the same. And now we want to apply the voltage at the input. Zero, and this voltage should be the AC voltage with the magnitude around 10 microvolts. What else? And we also want to do AC analysis. And more importantly, we need to give the models. And in this exercise, I have already included the model parameters in the comment section. So let's retrieve the model's parameters. So this is the model parameter, SPICE model parameter I'm going to use. I can just place it, copy and paste it. And where is my model parameter? The SPICE codes. Yeah, my god, I have to start from the beginning. C in VIN 100 mil. CO VVO 100 and V1 VV in 0 AC 10 microvolts. And then AC analysis. Um, 100 points per decade, and from 1 Hz to 1 gigahertz. And then we are going to place the SPICE parameter by doing Control V. Now everything should be okay now. And what happened to here? Oh, this is the resistor. Now let's do some SPICE simulation to see what happens. Model new value for Q1 IC is missing. It's here. NPN 54. And let's check what happened. Okay, wrong name. Let's try this. Now it's working now. It's working. So it's working. So let's delete this simulation window. But I have to correct the problem. In the symbol, in the icons, I need to correct the model name. 55 WDN. So that's what we get. And I also need to apply the voltage for the power supply. And here V2 VCC 0 DC, let's say 2 volts. 2 volts should be enough, good enough for this CMOS transistor. Yeah, let's start it again. do another SPICE simulations. Yes, it's working, and I got a very decent gain. Now, and you need to double check whether it's satisfied the DRC rule. So far, so good. Now the schematics has been taken care of. The next thing we are going to do is to do the layout. Before doing the layout for the common emitter amplifier, we need to create the layout view for NPN 1, NPN_1. So we create another cell with the same name, 1, and then the layout view. And we are going to pick some layout design from the MOSIS library. In the corner, in the left hand corner, we can pick a NPN transistor. And this transistor is very funny. They don't use N plus. They use P selected for the base, and then N selected for the emitter. And the layout for this transistor has a ring with a lot of contacts, and this ring is for the collector only. And at the entrance of this transistor and this green thing, we can route the metal across without disturbing the connectivity of the collectors. Again, we are going to do something very similar to the icon view. So first of all, we are going to develop a metal tracks, and this one is going to be the base. And I'm going to call this B, which stands for the base. Another thing is the emitter. Again, I'm going to do the same thing. And this one is called E, which stands for the emitter. And in the collector, I'm going to do the same thing. And I call this one C, which stands for collector. And very important, I can widen the metal track. And we don't want any decoration at the end of the track. So far so good. So this is the transistor we are going to use in our circuits, in our layout. Before doing this, we need to copy the SPICE codes. I don't know whether it's going to work. SPICE template. I hope it's going to work. and make it a little bit larger. Let's see, 10. Sorry, 10 is too big. 5. I hope everything is okay now. Let's check it. Okay. Now also I want to do a network consistent checks. So far so good. And the DRC check. So far so good. Now I'm going to create another view for the common emitter amplifier, which is the layout view. This view is the actual graphic for the integrated circuits. Again, I'm going to create a new cell, CEM, and layout view. CEM layout. And I'm going to place the transistor we have done, and we go down one level to display the inside of the layout of this transistor. Now then we are going to develop some resistor to complete the circuit. I need 3 different NML resistor. 1. This one is going to be connected to the B pins. For this one, I want $1K. And the width is 40. The length is I just forgot what is the best length for this thing. I think 16. Okay. I want another one similar to this. This one will be 0.9K, so I just need to shorten it a little bit. Say 14. And finally, I need a transistor, very small transistor. Copy and duplicate. This one is going to be 100 ohms, and the length here should be 1.6. So double check the DRC. So far so good. And I'm going to complete the connectivity of the circuit. And I'm going to widen this metal track 30 and without any ends. 30 lower, and then B in this capacitor. And here is to be connected to the ground pins. And the emitter. Apparently there's something wrong here now. I want this pin, the E pin, to be connected to the ground, and I want, let's double check. This is 1K, and this one is going to be connected to the power supply. Then what happened to here? There's no space. Okay, in this case, this one is changed to 0.9K. 0.9K. And 14. And this one is going to be this one is going to be 1K. 1K for this one, which is right. Okay, and this one is 0.9K. Okay, now I need a metal connection here, from here to here. See 1K in here. Yeah, it's better to do it this way. the metal track a little bit thicker. $30. As well, too big. Let's see. Maybe 20. Okay. And again I want 30. So far so good. So this looks like the view layout, and I'm going to clean up the pins everywhere. Let's check whether I have any DRC error. Okay, there's no DRC error. And this pin is going to be connected to an output. I will just I will need to so much. And I'm going to call this V in. In. Strange. In. Now it's working now. And this one is GND. And we want the one for VCC. And finally we also need a pin for the output. Oh, we just want 4. Perhaps we can make it a little bit thicker. Let's check whether I have any DRC error. Looks good. Now I can do the simulation on the circuits. We can use the same spike hooks on the layout. And the text is a little bit too small. I will make it slightly bigger. Let's check. Yes, it looks okay. And then finally we need a network consistency check. And let's see if we got any error. Okay, perfect. Everything is done. So this is going to be your common emitter amplifier. The layout. And this is the schematics. And we have also successfully created the NPN symbols and layout view for the same component.